Hello friends, how are you? Hope you are doing well. So today we are going to start one more discussion related to GHG emission inventory. A lot of examples are there, around 100 of examples. So it's a kind of marathon exercise we are going to do, and we'll see the different number of case studies and examples from different types of emission scopes, scope 1, 2, 3, and we'll see multiple number of examples. So as I said, 100 examples are there. So let us go one by one. Okay, first we will take example of scope 1 emissions, which is the emission description is given here. GHG emissions from company vehicles. So these are diesel vehicles basically, and let's suppose we assume that 200 liters of diesel consumption is happening. Okay, so what is the emission factor? Then how this emission factor was selected? So a standard diesel emission factor was taken, and this is the reference source, EPA and IPCC. And then see the calculation here, 200 liters, that's a quantity multiplied with the emission factor, and that will give you the answer for carbon dioxide equivalents. Okay, so the answer is coming 536. So let's see the detailed explanation about the emissions generated. So these emissions are generated through the combustion process of diesel, which is taking place inside the engine, releasing carbon dioxide, okay, carbon monoxide and nitroxides. Okay, so accordingly we calculated the equivalents, okay, for scope 1 emissions. Then next example is for again scope 1, which is about stationary combustion. We have a natural gas boiler which is using 5000 cubic meter of the gas. Okay, then this is the emission factor, 1.92 kg CO2 equivalents per meter cube, and this emission factor was sourced from IPCC guidelines for natural gas. So this is the reference IPCC. So how we do the calculation? 5000 meter cube multiplied with the emission factor, and that will give you the quantity of equivalents of emissions for this scope 1. Then from where this emission is coming exactly, as we know, there is a burning process or combustion process for natural gas in the boiler, okay, and which will produce carbon dioxide as a byproduct. Okay, then we have a scope 1. Again, one example, like we are having GHG emissions from refrigerant equipment. So there can be a possibility of refrigerant leakage, let's say, and the leakage is, let's say, 10 kg, and this is the emission factor, 2087.5 kg CO2 per kg of refrigerant. So this is according to the guidelines of IPCC for hydrofluorocarbons. Okay, and this is sourced from, emission factor is sourced from IPCC. So let's do the calculation now. In the calculation, if you will see here, this is about the quantity multiplied with the emission factor, which will give you the total value of the carbon dioxide equivalents. Okay, and these emissions are generated because of there is a possibility of the leakage of the refrigerants like hydrofluorocarbons, which might have higher global warming potentials, actually GWP values, global warming potentials, more than CO2, carbon dioxide. The next scope 2 emission example is like we have indirect emissions from the purchased electricity. Basically these emissions are coming from electricity consumption, and for example we have 5000 kilowatt hours consumption of electricity. Then what is the emission factor per kilowatt hour? Let's see. And this emission factor is selected based on the regional grid average, like there can be different energy sources, okay, electricity sources, basically either coal based, gas based or renewable based. So energy mix, we are talking about energy mix, and this is the local utility. Okay, as per the local utility we are selecting the emission factors, multiply the emission factor with the total quantity of the electricity consumption, which will give us the total carbon dioxide equivalents. Okay, and these emissions are generated from basically the combustion of fossil fuels like coal, natural gas in the power generation, even if the company does not directly burn the fuel. So this is indirect emission from purchased electricity, that's why it is scope 2. Another example of a scope 2 is like indirect emissions from purchased cooling energy. So in the cooling itself we are utilizing electricity. Okay, so let's say suppose 1000 kilowatt hours. Again there is a emission factor for this. So this we are taking from local grid mix for cooling, and again local power providers also we can consider to have this emission factor. So just do one thing, that multiply the quantity of the electricity consumption for required for the cooling purpose, and then multiply with the emission factor. You'll get the answer for the emissions, relevant emissions. Again, this is very similar to the electricity consumption. The cooling system also uses electricity from the grid, and that can be derived from either fossil fuels generating CO2 emissions indirectly. Okay, the next is scope 3 example. This is about purchased goods and services like office supplies. Around 500 units are there. Okay, for office supplies, multiply this with the emission factor to know the actual amount of the emissions. Okay, so we will do the multiplication of this, but from where this emission factor data was sourced. Okay, this is based on the life cycle data of the purchased goods and services. Okay, so we will get this information from supplier emission reports basically, and if you see the calculation, multiply the number of units purchased into the emission factor, you'll get the equivalent emissions. So these emissions are from the extraction of raw material, manufacturing, transportation of the goods. Okay, so basically following life cycle inventory life cycle assessment approach actually. So this includes packaging, production process, and shipping also. Next example for scope 3 is like purchased capital goods. So this is having office equipments, maybe a different number of units are being purchased, like 100 units we took example, and this is the emission factor. Again we are adopting the life cycle emissions for capital goods. This is sourced from EPA, Environmental Protection Agency in US, as an example we have taken here. Okay, and you see the calculation. So emissions generated from the production and transportation of capital goods like office equipments, and this includes raw material extraction and manufacturing process. So again life cycle approach adopted here. The next example we see here for scope 3 again, that is related to the fuel and energy related activities, and extraction of and transportation of the fuel. This is the emission source actually, and we have this amount of or quantity of 5000 liter fuel, and this is the emission factor. So this is we are getting based on the average energy related emission factors sourced from IPCC. Okay, and this is the calculation of the emissions. So these emissions are basically occurring during the extraction, refining, transportation of the fuel before it is even used in the company's operations. So again life cycle assessment approach we are applying here. Again scope 3 example like upstream transportation and distribution. So taking an example related to the freight transportation, let's say the freight is transporting 1000 kilometers multiplied with this emission factor. And how we get the emission factor? Basically the averaging of emissions from freight transportation. We took example this of emission factor from EPA website. Okay, and this is the calculation, multiply that one total number of kilometers into the emission factors. So again emissions are generated during the transportation of the products and materials from suppliers to the company using different type of freights like trucks, ships, or rail. So during the transportation of the product we have certain amount of emissions actually, and this is considered under upstream transportation and distribution. Then we have scope 3. The example is about waste generated in the operations, which is about landfill waste. This is the example, and let's say total quantity of the waste is which is going to the landfill 1000 kg, and this is the emission factor example like 0.15 kg. CO2 equivalents per kg of the waste we are sending to the landfill. So basically emissions generated from the waste disposal. Again, take an example of the source or reference of the emission factor EPA, and then we multiply this total quantity of waste sent to the landfill and the emission factor. So emissions are occurring when waste decomposes anaerobically, and in landfill this is producing methane gas, okay, which is again having higher global warming potential than CO2 and supporting GHG emission source. Okay, now we see the next examples. I hope you are liking the examples here which I have shared with you. In the next example, you see scope 3, we have business travel like air travel, but with the domestic flights only. Let's say suppose 100 flights were covered, and this is the emission factor, and this has been taken from the International Civil Aviation Organization calculator, okay, ICAO. Yeah, 100 flights, then multiplied with the number of kilometers, okay, and this is just example of the calculation, but this is the methodology we adopt, okay, and then multiplied with the emission factor, so you'll get the number of equivalent carbon dioxide, yep, equivalents. So emissions are generated from the combustion of jet fuel during air travel, then it will release CO2, okay, carbon dioxide and other greenhouse gases in the atmosphere, okay. So you can consider this example for air travel or domestic flight. Then scope 3 again for employee commuting, like using the cars for going to the work, okay, car commuting. Let's say the total travel is 5,000 kilometers multiplied with the emission factor. This emission factor is based on the averaging of emissions from commuting, again taken reference source EPA, Environment Protection Agency. What we do here in the calculation part, 5,000 kilometers multiplied with the emission factor, okay, we'll get the total number of equivalent carbon dioxides, okay. So these emissions are basically generated from burning of the gasoline or diesel in the personal vehicles which are being used for commuting to the work, okay, and during employees commutes to and from the work actually. Next example for scope 3 is upstream leased assets, like we are, for an example, leasing the offices, okay, and this is the square meter area what was leased, okay, and the emission factor for this. Then leased asset emission factors, okay, this is as per the local regulation. Emission factor has been taken from local regulations, let's say, and this is the calculation, total square meter multiplied with the emission factor. So emissions from the energy uses in the leased buildings, like for heating purpose, cooling purpose, lighting purpose, and again attributing to the company's lease of office space. Another example for scope 3 is like downstream transportation and distribution, and this is about the product distribution utilizing truck. We have taken as an example, total travel distance is 2,000 kilometers multiplied with the emission factor. This emission factor is coming from truck transportation emissions, like we have taken this from EPA, okay, as an example here, emission source example. So these emissions from transportation of the products from company to the distributors, okay, retailers and the customers. So basically it is about the product distribution, okay, and it's again under the scope 3. Next scope 3 example is like processing of the sold products, product processing. Let's say we have 1,000 units, this is the emission factor, and again it's based on the average emissions for the processing. We have taken example of EPA. These emissions are coming from processing and refinement of the sold products by the third parties, manufacturer or processor. So what is the emission calculation? We can say 1,000 units multiplied with the emission factor. So as I told you, this particular emission source is basically the further processing of the sold products actually by the processors or manufacturers. Next, scope 3 is use of sold products, like example of electronic uses, okay, we sold 500 units, this is the emission factor. Again we are adopting life cycle assessment approach, life cycle emissions from using phase. So this is what we are getting from the manufacturer reports, these emission factors. Okay, and these emissions from basically like electricity consumption during the use of the products sold. Okay, and this is like example electronics, machinery items. So there is a calculation for that. Then next, scope 3 is end of life treatment of the sold products, like e-waste recycling. Example, e-waste recycling, how many units we recycle? 1000 units. This is the emission factor. Emissions basically from the recycling process. Okay, like during the recycling, or if we go for incineration or disposal of the sold product after their useful life actually, but here we take example of the recycling. So emission factor reference, EPA, multiply 1000 units with the emission factor, you will get the answer for this. Then scope 3 calculation again for downstream leased assets, leased retail spaces. This is the example, retail spaces, let's say 500 square meter. This is the leased space, and this is the emission factor per square meter. The leased space emission factor as per the local regulation, as we have discussed earlier also. So basically the space which is leased, we are consuming the energy. So energy uses in the leased space, such as stores attributed to the company's lease. Next is example is scope 3 from the franchisees. Okay, franchise operations. Let's say suppose we have 100 stores. Okay, and this is the emission factor, basically 10,000 kg carbon dioxide equivalents per store. How come it is coming? Like franchise emission factors, this is coming from franchise emission reports. Basically the emission generated by franchise operations, including energy uses and other operational activities. Also, even we have the represents consumptions also. Okay, then scope 3, the investments. Basically the investment activities, like for an example, invested somewhere like $1 million US, and then per US dollar what is the emission factor actually, this is highlighted here. Then basically we consider this emission factor as per the investment carbon intensity. This is basically coming from the investment reports, and emissions are associated with the company's investments, such as carbon intensive industries, and which is basically generating the high emissions. Okay, so multiply with this emission factor whatever your investments are, or example of investment is, so you will get the total equivalent carbon dioxides. Okay, then next is again one scope 1 example, like we have a gasoline based generators. Okay, in this gasoline, direct GHG emissions from this fuel combustion, let's say 100 liter multiplied with the emission factor. And this again is standard gasoline emission factor, which is sourced from EPA. So when we are burning the gasoline during the combustion process, releasing the carbon dioxide in the atmosphere, so emissions for this particular scope 1 example. Then scope 2 again, indirect emissions from purchased electricity, which we have discussed, like electricity uses for lighting or illumination purpose. This is the total quantity of electricity consumed. Emission factor, the emission factor which is coming from regional energy grid mix or electricity mix. Okay, grid mix, local utilities, and then of course the electricity consumption multiplied with the emission factor, you will get the answer for this. So emissions, these are indirectly generated by the production of electricity used for illumination, lighting purpose, which comes from fossil fuels based energy sources. But when we say grid mix, so definitely there can be certain proportion of renewable energy mix, also electricity mix. Scope 1 again, GHG emission from the company fleet, again mobile combustions using the gasoline vehicles or petrol vehicles, total quantity of the gasoline used or consumed, and this is the emission factor. Source of emission, EPA and IPCC. Okay, so direct emissions from the combustion of gasoline in the company vehicles producing carbon dioxide. So this is the calculation for total emissions for this particular example. Then again one more example for scope 3, which is about the upstream transportation and distribution using the rail transportation. Okay, and if you see here, this 1000 kilometer travel by the rail, this is the emission factor. So again, average emissions we are using here from rail. Source of emission factor, EPA. Calculation for this 1000 multiplied with the emission factor. So emissions generated by the transportation goods by rail using diesel or electric powered locomotives actually. So these are the examples for different scope 1, 2, 3. Let us consider more examples. I hope you are liking this. Thank you.